Hello students, good evening. I'm your physics teacher Vikal, and today we are going to start heat engines. It's very simple. हीट इंजन अभी समझ लेते हैं 1 मिनट में, ठीक है। हीट इंजन क्या होता है? हीट इंजन हमारी जो डिवाइस होती है उसका काम क्या होता है? टू कन्वर्ट हीट इनटू वर्क. Simple. To convert heat into work. It's a device which converts heat into work. Simple. तो हम लोग देखते हैं हमारे डेली लाइफ में जो हमारे बाइक होती है, कार होती है, बाइक, कार, all the power plants, or we can say like aeroplane. All those automobiles works on heat engine. So what happens in that engine? What happens? There will be some fuel. That fuel burns. Okay, that fuel burns, and the burning of fuel will provide some heat to the engine, and that heat will convert into work, and because of that work, wheel rotates. Our automobile, that car or bike, will move. Okay, so that is the function of heat engine. ठीक है. So heat engine work कैसे करता है? Heat engine works between two temperatures. One temperature will be source. Source means you can see source of heat from which it takes heat. That engine will takes heat. Okay, that engine will take heat from the source. Okay, तो source जो हमारा हो गया वो हो गया petrol, diesel. Okay, in power plants it can be coal. Okay, it can be steam. Okay, so these are the source of the heat from which it will take. Okay, so from source you can see Q1 amount of heat is taken. इंजन ने Q1 amount of heat सोर्स से ले लिया. ठीक है, अब क्या होगा? कुछ वर्क डन हो जाएगा उससे, उस इंजन से, उस Q1 amount of heat से क्या होगा? कुछ वर्क डन हो जाएगा. ठीक है, so some work is done by that engine, or some heat will be rejected. Q2 amount of heat will be rejected to the sink. So in practical life, like in all the engines, that sink will be used as like it will sink is our environment or atmosphere. Our atmosphere or environment, we can say that is sink. ठीक है, जैसा कि हम लोग जानते हैं हमारी जो गाड़ी होती है, कार होती है, जो बाइक होती है, उसका जो साइलेंसर होता है, उसका जो एग्जॉस्ट होता है, वो धुआं कहाँ छोड़ता है? और एनवायरमेंट में छोड़ता है. दैट इज व्हाट? दैट इज Q2, दैट इज हीट रिजेक्टेड. ठीक है, हीट सप्लाइड इज व्हाट? हीट सप्लाइड इज बाय सोर्स, एंड दैट सोर्स इज पेट्रोल, डीजल. इन द बाइक इंजन, दैट पेट्रोल बर्न्स. Okay, that burns, and that because of burning of petrol, some heat will produce, and that heat will be supplied to the engine. Okay, so because of heat, what happens? Pistons start to move. Then what happens? Because of movement of piston, the wheel start to rotate. Okay, so we are getting work, and some heat will be rejected to the surrounding or our atmosphere. I hope all of you understood how heat engine works. Okay, so by first law, we can say, first law says energy conservation. First law is what? Energy conservation. Okay, so according to first law, we can say how much heat is supplied, that all heat can convert into work. That all heat can convert into work. But that is wrong. Practically we can see. No engine can have 100% efficiency. No engine can have 100% efficiency. Practically we know. Okay, so no engine can have 100% efficiency, and that is what? That is our second law of thermodynamics. See, फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स तो क्या कहता है कि जितना हीट है, जितना एनर्जी है, वो सारा हम लोग का क्या है? कंजर्व है. मतलब हीट, जितनी हीट सप्लाई की उतना का वर्क हम लोग ले सकते हैं. बट उस पे लिमिटेशन कौन लगाता है? उस स्टेटमेंट पे लिमिटेशन लगाता है हमारा सेकंड लॉ ऑफ थर्मोडायनेमिक्स. सेकंड लॉ ऑफ थर्मोडायनेमिक्स सेज नो इंजन कैन हैव 100% एफिशिएंसी. ओके, दैट मींस जितना अमाउंट ऑफ हीट हमने लिया, अमाउंट ऑफ हीट absorbed by the engine cannot convert totally into work. There should be some heat rejected to the surrounding or to the sink. ठीक है, समझ आया? So like this engine works. And engine is what? Engine is a cyclic device. इंजन में क्या होता है? इंजन में जो हमारा पिस्टन सिलेंडर होता है, पिस्टन सिलेंडर, इट्स लाइक अ पिस्टन, सॉरी इट्स लाइक अ सिलेंडर एंड इट्स पिस्टन. सो यहाँ पे क्या होता है, यहाँ पे जो फ्यूल होता है बर्न करता है, फ्यूल बर्न होता है, तो क्या होता है, पिस्टन मूव करता है, पिस्टन मूव करता है और फिर दोबारा से वहीं आ जाता है. मतलब क्या हो रहा है, साइक्लिक प्रोसेस है. देखो पिस्टन मूव किया ऊपर और फिर दोबारा नीचे आ गया, फिर ऊपर मूव किया फिर दोबारा नीचे आ गया. तो ये क्या है, हमारा साइकिल है. यू कैन सी इट इज अ साइकिल. So heat engine works on a cyclic process. So it's a cyclic device. ठीक है. चलो अब देख लेते हैं इसकी एफिशिएंसी क्या होती है. जो एफिशिएंसी हम लोग डिनोट करते हैं वो ईटा इस सिंबल से डिनोट करते हैं. एंड एफिशिएंसी इज व्हाट, आउटपुट डिवाइड बाय इनपुट. सिंपल, आउटपुट डिवाइड बाय इनपुट. तो आउटपुट क्या है हमारे पास, आउटपुट है हमारे पास वर्क, कितना वर्क हम लोग को मिला, हाउ मच वर्क वी गॉट फ्रॉम दैट इंजन, W, that is output. And input is what? Input is what? Input is कितनी हीट उसने ली उस वर्क को करने के लिए, how much heat that engine absorbed or took from that source. Okay, so Q in, how much heat absorbed, that is input, and how much work is done by the engine, that is output. कितना मिला हम लोग को. ठीक है, तो ये हो गया हमारा एफिशिएंसी. और फॉर cyclic process, we know delta U is 0. ठीक है, engine works on cyclic process, so for engine also delta U, change in internal energy, will be 0. ठीक है, तो हम लोग जानते हैं फर्स्ट लॉ क्या बन जाती है हमारी, डेल्टा Q इक्वल्स टू डेल्टा W. ये हो जाती है हमारी फर्स्ट लॉ. डेल्टा W कुछ नहीं होता, सिंपल वर्क होता है, तो डेल्टा W नहीं लिखेंगे हम लोग, डेल्टा Q इक्वल्स टू W. ठीक है, तो डेल्टा Q इक्वल्स टू W. तो कितना चेंज हो रहा है हमारा उसमें, Q in minus Q out, that is change in heat, that is equals to W. Heat supplied to the engine. तो heat supplied हमारी किस किस चीज में यूज हुई, that heat supplied is used as some work done and that some heat is rejected to the system. तो हम लोग सिंपल क्या लिख सकते हैं, Q in minus Q out is equals to W. कुछ लिया हमने और कुछ बाहर फेंक दिया, बचा क्या, वर्क डन, दैट इज W. समझ में आ गया. तो Q in minus Q out equals to W. तो W की वैल्यू हम लोग यहाँ पर पुट करेंगे Q in minus Q out. तो ये हो जाएगा Q in minus Q out divided by Q in. So if we will write like this, Q in divided by Q in will become 1 minus Q out divided by Q in. That is another formula of efficiency. Okay, so these are two formula of efficiency. One is W by the work done divided by heat supplied, that is heat supplied. Heat supplied, कौन heat supply कर रहा है, heat is supplied by source temperature. ठीक है, so efficiency equals to W work done divided by heat supplied, or we can write 1 minus heat rejected divided by heat supplied. ठीक है, so like this we can write efficiency of the heat engine. Okay, one more thing we have to remember, for an ideal engine, for an ideal engine we can write efficiency equals to 1 minus T H upon TL upon TH, wait, that is TL upon TH. This is one more formula. We will derive it in Carnot cycle. Day after tomorrow we will do the topic. Okay, so one more formula you can write. This formula is for any heat engine and this formula is for ideal heat engine. Ideal heat engine is also known as Carnot engine. Carnot engine we will study separately. Okay, chalo. Last problem is the efficiency of an ideal heat engine working between the freezing point and boiling point of water is. As I told you, what was efficiency of ideal heat engine? That was 1 minus TL upon TH. Higher temperature, sorry, lower temperature divided by higher temperature. So you can see what is the lower temperature, this freezing point. What is the higher temperature, boiling point. तो हम लोग जानते हैं जो freezing point होता है वही हमारा TL है, and that is what, 0 degree Celsius. But here we cannot put temperature in degree Celsius, we have to put it in Kelvin. So 0 degree Celsius will become 273 Kelvin. And what is boiling point? That is हमारा TH, and that is what, that is 100 degree Celsius. 100 degree Celsius, if you write in Kelvin, that will become 373 Kelvin. Put these values here. So 1 minus TL is what, 273, and TH is what, 373. If you will take LCM, 373, and here 273. So it will become 373 minus 273, 100. 100 divided by 373. Okay, if you want to find efficiency in percentage, then multiply 100. So multiplying 100, you will get efficiency, and that is what, if you will solve it, you will get 26.8%. Okay, 26.8%. Okay, so I hope all of you understood how to find the efficiency of engine and what is engine, how it works. Okay, so for today, that's it. If you are new to this channel, please subscribe, like the video, and share with your friends. Thank you.